Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in the second session of Elements, Compounds and Mixture, we are going to discuss with the mixtures and its types. So before starting with the new session, let me give you a recap of the last session. We learned the general characteristics of elements, compounds and mixture, which says it is the simplest of the substance. For example, carbon, hydrogen and oxygen, etc. are all the elements formed by a same kind of atom. And if we talk about the compound, it is the combination of two or more elements chemically combined together. For example, water, carbon dioxide, HCl are the compounds. And if we talk about the mixture is nothing but a mixing of two or more elements or compounds together, but they are not chemically combined together, so they are called mixtures. So friends, let's start with a new session with the mixtures and its type. To make the session more effective, let me give you a brief of the session. So friends, we all know that mixture is a matter, and matter is segmented by pure and impure substances. In pure substances, we learned elements, and in impure, we learn compounds and mixtures. Mixtures are basically broadly segmented into two sections, which we call as homogeneous and heterogeneous, right? These two are basically a broader view of mixture, which we'll be discussing later in this session. But let me give you first a very daily and very routine example so that you can have a clear view of a mixture. For this, let's do a small activity, right? Let there is a box. Say there are 5 boxes, and there is a big box. In first box, we have small red pebbles, right? In the second, we have a green pebbles. In the third, let it have a purple pebbles in it. Pebbles are these small stones, shining stones. Fourth one is having dark green pebbles. And fifth one is having magenta color of pebbles. Now what you have to do, you have to close your eyes and put some pebbles from each of the box in the main box. Let the purple have 2 pebbles. Here we get 2 of the blue one, 3 of the light green, many of the dark green, and some of the red one. So when you open your eyes, you'll see your final box have many of the pebbles of the different colors. So what do you say this box is having? You will say it is a mixture of all the pebbles of all the colors which you have in the individual boxes, right? So this is a kind of a mixture. So what will be the characteristics of this when you actually start the activity? Did you saw this? The actual characteristics of the mixture. You didn't measure the pebbles, that is the number of pebbles when you were putting in the main box. Second, you find the non-proportionate numbers of pebbles. Third, let's write here, you find there is no color combination in the main box. So now, if we want to define chemically what would be the mixture now, in terms of chemistry, it would be a substance which contains two or more, either it will be elements or compounds. But yes, let me give you a highlighted note that they are not chemically combined together, right? So this is actually a mixture. So what would be the examples you see in your daily life? You see air, which is a mixture of many of the gases. You see milk, mixture of many vitamins and minerals. You see petrol. You have tea. It is also a mixture. Tea, coffee, right? So friends, now let's see and discuss the new session. So now you are be able to define the mixture. So as a definition, we'll be saying that a mixture is a substance which consists of two or more elements or compounds not chemically combined together. And if you like to have an example, that air is a mixture of gases like oxygen, nitrogen, argon, carbon dioxide, water vapors. So now friends, as we have seen in our daily life, we deal with many kinds of mixture like solid in solids, solid in liquids, liquid with liquid, liquid in solids, gas in liquid, liquid in gas, and gas in gas. Are you confused now? So let me give you an explanation about this. Types of mixture. Friends, in many sessions we will be discussing about the physical composition of matter, which have solid, liquid, and a gas. So can solid and liquid be combined together to form a mixture? Or liquid or gas can combine to form a mixture? Can solid and solid be combined to form a mixture? Yes, it can. So mixture may exist in any state of matter, that is solid, liquid, and gas, depending upon the physical state of its components. Friends, what is components? Components is nothing but a mixture having component, that is the contents used in mixture. Like if we talk about the air, the many gases are the components of the mixture, that is the air. So now if we talk about the physical composition of matter with respect to the mixture, we have many combinations which come and we see in our daily life. First, if we talk about the solid in solid, we can have an example of gunpowder, or you can see if we combine salt plus sugar, it is a mixture, that is a solid-solid mixture. Now if we talk about the solid and liquid, it is a very common example you can see in our daily life. We have a tea, coffee, right? Or you can have a sand in water. Third combination will be the liquid-liquid. Again, there is a very basic example, milk plus water. Or you can also see the petrol is also a mixture. Fourth combination is nothing but liquid in solids. This is basically a very rare kind of combination. We don't see in our daily life. We see it very often, like water in a sponge, right? And now we talk about the gas in liquid, like oil in a water. Friends, it is not a rocket science. If you see the things around yourself, you'll yourself find many examples of mixture and combinations of the mixture around you. So, we talk about now the liquid in gas. We can have a helium in water, or you can see a water vapor in atmosphere. What about the gas in gas? It is nothing but the air. So friends, these are the very simple combinations which we see in our daily life, which are either used by us or are in surroundings of the nature, which we actually called mixture. So now friends, these are the combinations. Now what are the broader types of mixture? What is the broader segmentation of mixture? For example, if you see milk and water, can you separate them? No. Now I give you another example. Water and a sand, can you separate them? Yes, of course. There are two types of mixture. We have heterogeneous mixture and homogeneous mixture. These mixtures are very often seen in our daily life. Like if you talk about the heterogeneous mixture, which is nothing but a non-uniform composition throughout its mass. That is, for example, if you see sand and water, after the sedimentation, you can see water and sand completely individually. So it is a visible boundary of separation between the various constituent of the mixture, which is the heterogeneous. And if you talk about the homogeneous mixture, it is nothing but a mixture has a uniform composition throughout its mass. So it has no visible boundaries of separation between the various constituents. If I give you an example of sugar and water, we call the sugar solution, which is a homogeneous mixture because all the parts of sugar solution have the same sugar-water composition and appears to be equally sweet. So there is no visible boundary of the separation between sugar and water particles. If we're comparing with the second one, that is the heterogeneous, the mixture of sugar and sand is a heterogeneous mixture because different parts of its mixture will have different sugar-sand composition. Some parts of this mixture will have more of sugar particles, whereas other parts will have more of sand particles, as there is a visible boundary of separation between sugar and sand particles. So now we can now define homogeneous mixture, which is it is the uniform composition throughout its mass and it has no visible boundaries of separation. Heterogeneous mixture. It does not have a uniform composition throughout its mass. It has visible boundaries of separation between the various constituents. We can also subdivide it or subsegmentate the heterogeneous and homogeneous with three definitions. That is, heterogeneous can also be subdivided into two sections, colloids and suspensions, and homogeneous can be further arrowed down to the solutions. We'll not be discussing these three terms in this session. We'll be doing in the further future sections. So let me first give you the example so that we can understand the properties of mixture by a very small example of iron and sulfur. We'll be having two experiments. First, we'll be taking the equal amount of sulfur and iron powder and grind them together thoroughly in a mortar, and we'll see the properties of a mixture in that particular mixture. And the second one, we will be seeing the effect of heat on the mixture of iron and sulfur. So let's understand the experiments. Experiment 1 will be taking equal amount of iron and sulfur that we will be taking in the powder form and grind them thoroughly. So what are the observations we'll be having after we'll be seeing the particular mixture in the magnifying glass? We'll be seeing the grayish yellow substance which is produced, showing the properties. First, the gray particles of an iron and yellow particles of sulfur will be seen, that are gray and yellow particles are seen, right? So in some parts there is an excess of iron, in some other parts there is an excess of sulfur. So what is the type of mixture we are having? Yes, we are having a heterogeneous mixture, right? In the second observation, we have all the individual particles of iron and sulfur will be shown separately by the mixture. So the iron particle will be attracted by a magnet and sulfur will be dissolved in carbon disulfide. Let's write down. Iron will be separated by magnet and sulfur can be separated by dissolving in carbon disulfide, right? So these are the two observations. With this experiment, we get to know that this mixture is a heterogeneous mixture. So what are the methods by which we can separate these two components of mixture? First by magnet and second by carbon disulfide, that is sulfur is dissolved in carbon disulfide. So what the conclusion we get in this experiment? We conclude that since the components of grey powder could be separated by a physical method, so it is obviously not a compound but is a mixture. Now let me give you the details of the second experiment, where we have to see the effect of heat on the mixture of iron and sulfide. That is experiment 2, effect of heat on the mixture. By this effect, we see that we observe in this experiment that we see only one substance, which means it is a homogeneous composition. Why? Because when we take the above mixture in a hard glass tube and heat the glass tube, first gently and then strongly, the powder will be appear to melt and the pungent smell of gas will be given out. So allow the tube to cool, a dark grey solid will be produced. Break the tube and remove the broken glass separates the grey mass of iron sulfide. If we grind it to a powder and absorb in the magnifying glass, we see this effect. Thus now, after heating, the heterogeneous mixture has been converted into homogeneous mixture. Let's highlight this. Right? And we also conclude with this observation that it is neither attracted by a magnet or not it is a soluble in carbon disulfide. Obviously, it is not more a mixture rather than it's a compound now. So now we conclude in this. Let's first write down that now it is a compound. Why? Because it has not been separated by physical method. Let's cross. And not it is dissolved in carbon disulfide. So now it is a compound. So we conclude that since a large amount of heat is involved in this experiment, so the interference is that the two elements are now chemically combined together to form a substance with the new properties, which we call now a compound. So friends, I hope now you have now a good understanding of the mixture. So by this I end up with the session. Now I'll give you one very simple activity with the two questions in it. First is what is a mixture, and second you have to prepare two kinds of mixture. First with the liquid, second the liquid, third with the solid and liquid, and fourth with the gas and gas in your notebooks. So in next session we'll be discussing with the solutions, which is the homogeneous mixture. Thank you.